10.1 Parabolas. Parabolas are a conic section, and it's made when a plane cuts through the cone at an angle, like you see in that picture right there. Of course, there are other conic sections, a circle, an ellipse, and a hyperbola, which we'll get to, but today is parabola. Now, we've already done parabolas before, but mainly what you saw looked something like this: y equals x squared. And you could have different numbers attached to that, but we would know that mainly this is going to look something like this. Well, today we're going to see other forms of parabolas, including ones that open left or right, not just up or down. In algebra class, we only had parabolas that opened up or down because they were functions. Remember the vertical line test? Now we're going to be talking about parabolas that open the other way. We're going to open sideways. So one interesting and thing you need to know is that's not a function, and you're not going to be able to use your TI to graph those. So we're going to have to be able to graph these by hand. So if you look at the formula, you've got the minus h and the minus k. That should look familiar to you from the last section when we talked about circles. Okay, except we don't have a center point for a parabola. We have a vertex. And so when we look at this equation, that minus h and that minus k is going to give us the vertex of the parabola. We look at this number a in the front, and if a is positive, the parabola opens to the right. That's the positive x direction. And if a is negative, it opens to the left. That's the negative x direction. Okay? Example 1, graph x minus 4 equals negative quantity y plus 2 squared. Give the domain and the range. So it's pretty easy. You should be able to immediately pick out the vertex here. The vertex is going to be positive 4 and negative 2. Just like when we found the center of a circle, it's the exact same deal. So we know the vertex is at positive 4, negative 2 right there. All right. We would also know, if you're looking at this problem, ignore all the numbers for a second and see how it says x equals y squared. Since it's x equals and y squared, that's kind of how you know it opens left or right. But then you look at that a number. See this negative sign in the front tells me that a is negative 1. So it's going to open in the negative x direction. I know from that a number that this opens left. Think about before when you did this in Algebra 1 class, that negative meant it opened down. It opened in the negative y direction. Well, this one's going in the x direction, so this opens in the negative x direction. It opens left. So you already kind of know what this looks like. It's going to be a parabola that opens to the left. Now that's not going to be good enough, so we have to nail down some more specific points. Okay? A equals negative 1, and so basically you can think about that as doing just the 1, 3, 5 pattern. Multiplying by a negative doesn't change the numbers, it just changes their direction. So there's definitely going to be a 1, 3, 5 pattern. I'll come back to that later. Let's see what, if you didn't know the 1, 3, 5 pattern, you'd have to make a table. So let's look at that. So in this case, in this equation, really you can plug in for x or y. It doesn't really matter. I'm going to start off and I'm going to plug in a number for y. I'm going to plug in 0 for y. You can see when I plug in the 0, I just follow the equation, I follow the math, I follow the order of operations, and when I plug in y equals 0, I would get out x equals 0, and so I would have the ordered pair 0, 0 as one of the points on my parabola. Now here's another shortcut you can use. Every parabola has an axis of symmetry, and so if we look at the axis of symmetry, since we know it opens to the left and the axis is going to go through the vertex, there is the vertex, okay, what we can do, since we have that point at 0, 0, we would also have its mirror image point 2 on the other side of the axis. we would have that point just by symmetry. Okay, so now we kind of have a little bit better idea of what this parabola looks like. So maybe I need to plug in some more points. Maybe I need to do something else. So we're going to do another number. This time I'm going to plug it in for the x just to show you what happens. So let's say this time I plug in 0 for the x coordinate. Okay. So if I plug in 0 over here, now that's kind of weird to do. Normally, maybe I shouldn't do that since I already know if I plug in 0, I'm going to get 0. So maybe I won't plug in 0. Maybe I'll plug in -5, let's say. So if I plug in -5 for x, you're going to see that the math looks kind of complicated, but all I did was plugged in -5 for x, and I'm trying to find y. When you get down to the to this step, you're going to have to take a square root of both sides. You have to do plus or minus square root. So you end up getting a plus or minus 3. And then the last step to solve, you subtract 2. So you have plus or minus 3 minus 2 down here at the bottom. Plus 3 minus 2 is 1. -3 minus 2 is -5. So you actually have 2 points here. You have the point, remember we plugged in -5, so you have -5 comma 1. And you also have -5 comma -5. So when we graph that, we actually have 2 points. -5 comma 1 is right there. -5 comma -5 is right there. Now we didn't really need that because we could have used symmetry. But we've got 5 points for our sideways parabola, and that's probably going to be good enough. All right, now keep in mind, this is a U shape, it's not a V shape, so don't make it pointy even though it looks pointy. So do your best to draw a parabola through those points. I find that it helps if I trace over it. Sometimes I can iron out some crooked spots. Okay, so there is my sideways parabola. Now, think about if I had done the 1, 3, 5 pattern. Now that I'm finished, now that I did all that, look at the 1, 3, 5 pattern. You would have started at the vertex, which was at 4, -2, and what we would do is we would go, since we know it opens left, we go over 1 and up 1, over 3 and up 1, over 5 and up 1. There's our 1, 3, 5 pattern right there. It's just sideways. So we can go over 1, over 3, over 5, and we get those exact same points using the pattern. So if you know that pattern, if you recognize that pattern, that'd be a great shortcut to use. Now don't forget we have to give the domain and the range. So domain and range, domain we're talking about the x numbers, so imagine squishing it down onto the x-axis. It's going from all the way over at -infinity to the vertex, which is at 4, but notice it can equal that point, so we'd have a bracket there. There's your domain. Your range is going to be the y numbers, so imagine squashing it onto the y-axis, and everything's going to be covered, all real numbers. Example 2, graph this function, give the domain and the range. So when I first look at this, I immediately see that it's an x equals y squared. And so I immediately know that since that 1/2 is a positive number, I know that positive y squared is going to open to the right. Okay? So I automatically know that just by looking at the problem. So let's put this in vertex form, and let's factor out the 1/2. So if you factor out a 1/2, it's a little bit harder to do because you have to figure out what makes that -4. So think of it as multiplication. 1/2 times 8y would give me that 4y. Plus blank, and then plus the 6. So we factored out that 1/2, and you can test it by distributive property if you need to, but half of the -8 is -4 square, that is 16. And so your square would be y minus 4 squared. You got the 1/2 in front of it. But we messed up our equation, not by 16, but half of 16, which is 8. So in order to balance this out, I'm just going to subtract 8 to balance out my 1/2 of 16 that I threw in there. So at the end of this equation, you're going to have the 6 minus 8 is -2. And so we have the equation x equals 1/2 times quantity y minus 4 squared minus 2. I would probably go ahead and add the 2 over and see x plus 2 equals 1/2 y minus 4 squared. At this point we can see the vertex, the x part is -2 and the y part is 4. So remember, we know that this opens to the right. We've got a vertex at -2, 4. And we've got a parabola that opens to the right. Okay, so we have to sketch this thing. We have to graph this thing. And normally I would make an XY table, but I think I'm going to try to use the pattern this time. So when you're talking about parabolas, and we know this is a parabola, remember we've got that 1, 3, 5 pattern. But since you have that 1/2 number in the front, the 1, 3, 5 pattern is going to get multiplied by 1/2. And so instead of 1, 3, 5, cut it in half, you've got 1/2, 3/2, 5/2. Or if you need to look at decimals, it'd be 0.5, 1.5, and 2.5. So here's how the pattern works. If you don't understand this, that's fine. We can always make a table, but here's how that pattern works. I'm going to start at my vertex, and in order to make this work, you have to understand that we already know this is a parabola that opens to the right. So start at that vertex, and you're going to go to the right by 0.5, and either up or down. And then from that point that I just drew, you're going to go to the right by 1.5 and either up or down 1. And then from that point, you're going to go over 2.5 and up or down 1. And so we're going to have a parabola that goes through those points. If you can draw a smooth curve that fits through that, you're in pretty good shape. Going to look something like that, more or less. Okay, so there is our parabola. We need to give the domain and the range. So domain, remember it's the x numbers. Looks like it goes from -2 inclusive to infinity. And the range is the y numbers. The possible y numbers would be all real numbers, like that. Okay, so I like using the pattern. If you don't like using the pattern, you're going to have to come back and do a table. And you can do that. It'll just probably take you a little longer. So imagine if you look at this equation, it's set up pretty well to plug in a y number and figure out an x number. So let's say I let y equal, I don't know, let's just let y equal 0, let's say. That's usually a pretty easy number to plug in. You plug in 0, you have 1/2 times 0 squared minus 4 times 0 plus 6. All that 0 stuff's going to cancel out. You're going to get the 0.60. And so you should have a 0.60 on your curve right there. Okay. Now, if you understand symmetry, you can almost always figure out another point by symmetry. And if you think about it, that point that I just graphed was 1, 2, 3, 4 under the line of symmetry. So you should be able to go up 1, 2, 3, 4. And there should be a point there that's symmetric as well. So you can see I kind of drew my parabola a little bit off, but it's still pretty close. A parabola is the set of points in a plane equidistant from a fixed point and a fixed line. The fixed point is the focus, and the fixed line is the directrix of the parabola. So imagine a line and a point. If you take all of the points that are equidistant, okay, equidistant from that point and from the line, we're talking about a parabola there. Okay, now if you don't understand what I'm talking about, what I'm saying is if you take any point on this parabola, then it should be the same distance. I know that doesn't quite look right, but it should be the same distance from that point and from that line. Any point on the parabola, obviously the vertex is the easiest one. It's equidistant from the point and from the line, but that's what we're talking about. That's the definition. So that point is called the focus, and the line is called the directrix. So we have some different properties, and you should try to read through this chart. They give you the formula in this form or this form, and that's kind of backwards from the way we usually see it. We usually see it with the non-squared variable isolated. So if you isolate, in the top case, if you isolate the y, it would look like y equals 1 over 4p times x squared. And so that looks a little bit more like what we're used to, where that 1 over 4p is just whatever the coefficient is. And so similarly down here, if you isolate the linear term, the x term, you would have x equals 1 over 4p times y squared. So we can tell that the one on the top opens up or down, and the one on the bottom is going to open left or right. Okay, but one thing to notice is that 1 over 4p is equal to the a coefficient that we normally would see in our equation. So that's going to be useful for us for finding the focus or finding the directrix. Okay, because we're going to have to find p. They're going to give us a definition of a focus as being this point or this point. Notice it's either 0p or p0, depending on which way it opens. If the parabola opens up or down, then the focus, that point right there, would be your y number. If the parabola opens left-right, then the focus is that point right there, and it would be like the x number. Okay. So one tip maybe that you can remember is this: if the focus is in the positive direction from the vertex, P is going to be positive. Okay, so what I mean is it's kind of telling you which way it faces. So the focus is in the positive direction from the vertex of this parabola, and so that p-value would be positive. And likewise down here, the focus is in the positive direction from the vertex of that parabola. So it's telling you what direction the thing's facing, if it's positive or negative. Okay, so if the focus is in the negative direction, then p is going to be negative. So I'm talking about if it's opening down or left. Example 3, give the focus, directrix, vertex, and axis of the parabola x squared equals negative 4y. So to start this problem, I don't like how it's written. I would isolate the y. I think we're probably more comfortable if we isolate the y. So I'm going to divide both sides by negative 4 to see that y would equal negative 1/4 x squared. So my a coefficient right there, that's telling me, I know what this looks like. It's going to open down. It's going to be a parabola that opens down. And my focus is going to be inside there. I can already tell. Okay. You can see the vertex would be at 0, 0. We can already tell that. And we know the vertex is at 0, 0. We know it opens down. We know several different things, but we have to find the directrix and the focus. So use that formula that I gave you, a equals 1 over 4p. And know that a is this coefficient in front of the squared term. So a is negative 1/4. Negative 1/4 equals 1/4 p. We want to solve that equation, so I think the best thing to do there is probably cross multiply. We don't like that variable on the bottom. So if you cross multiply, you'd have negative 1 times 4p. That's negative 4p equals 4 times 1 is 4. And so, of course, divide by negative 4. P is going to equal negative 1. Now, remember what I said. If p was negative, okay, p is negative, so that means that the focus is in the down direction. Well, we already knew that, okay? We already knew that the focus was in the down direction based off just knowing what the parabola looks like. But that one part is the distance. And so really that tells me what direction the focus is in, but it also tells me it's a distance of 1 away from the vertex. So there's where your focus is, okay? It's 1 away from the vertex in the negative y direction. And so we should be able to say that the focus is the point 0, negative 1. Now the directrix is just going to go in the opposite direction. So it's still a distance of 1, but it's in that other direction. It's in the positive direction. So we can draw it in right here is the directrix, and that's going to have a y equation. Directrix y equals 1. So we've got pretty much everything. We've got the vertex, we've got the focus, we've got the directrix, we don't have the axis yet. The axis of symmetry, remember, the axis of symmetry is going to be that middle line. It's a dotted line right through the middle, right through the vertex. That's going to be an x equation. The axis of symmetry is going to be x equals 0. So let's go ahead and put the vertex back down here, 0, 0, just so we can have it all. This is all that information that they wanted. And then they want me to graph it. Use that information to graph the parabola. Well, I'm going to use my, well, I guess I could use my 1, 3, 5 pattern. That's kind of tough, though. Your 1, 3, 5 pattern is getting cut, or it's getting multiplied by negative 1/4. So really, it'd be negative 1/4 and negative 3/4 and negative 5/4. So that might be kind of tough to graph. So maybe we should just make a table. So if I make a table, I might plug in like positive, let's see, let's plug in x equals 1. So if I plugged in x equals 1, that would be 1 squared equals negative 4y. And so divide by, that's going to be 1, negative 1/4. Y equals negative 1/4. So 1 comma negative 1/4. Ugh, that's kind of hard to do. Symmetry would give me this point over here. Let's try something maybe better. Let's try, if I plug in positive 4, maybe that'll be easier. 4 equals, let's see, 4 squared equals negative 4y. 16 divided by negative 4. That's going to give me y equals negative 4. So 4 comma negative 4, 4 comma negative 4. All right, that's more like it. At least I don't have to deal with fractions there. I would have a symmetrical point over here. I'd say that's probably good enough. We've got this parabola. With focus at the point 0 comma negative 1. And a directrix at y equals 1. And of course your vertex was at 0, 0. And your axis was x equals 0. Example 4, write an equation for a parabola with focus 0, 3/4 and vertex at the origin. So let's just think about what this looks like. Okay. If we've got a parabola with a vertex at the origin and a focus at 0, 3/4, that's going to be right here. So then you should know that the parabola is going to look something like this. Okay? So that is in the positive direction, so I know that p-value is going to be a positive 3/4. So we want to find the a value, and remember we've got a equals 1 over 4p. So just plug in that 3/4 for p. 1 over 4 times 3/4. 4's cancel, leaving me with 1/3. A equals 1/3. So we can see that this equation, since it's facing up like this, we know it's a y equals x squared. And so the vertex at the origin means y minus 0 and x minus 0. So we can just say y equals 1/3 x squared. Obviously, if it wasn't at the origin, we'd have to shift, you know, the y minus 2 and the x minus 4 or whatever. But at the origin, that's what it looks like. And so they give us these equations for if we're not at the origin. But again, I don't like the form. I like it better when the linear term is by itself. So shifting this equation around a bit, I would have y minus k equals 1 over 4p times x minus h squared. Looking at the other one, we'd have x minus h equals 1 over 4p times y minus k squared. So I like those forms a little bit better. It's the same thing. If you'd rather use this, but I like the second way better. Example 5, write an equation for parabola with vertex -2, 3, and focus -2, 2, then graph the parabola. Okay, so knowing what I know, okay, I know that the p-value is going to be negative because that focus is in the negative y direction from the vertex. But you can look at that distance right there. That distance is 1, and so that's all it is. It's a -1 is your p-value. So we don't really want that graph in there yet. So we just have p equals -1. And we've got our equations still. A equals 1 over 4p. So if you substitute in that -1, a is going to equal 1 over 4 times -1, or a is going to equal -1/4. That a value is really important because that's our coefficient. So we're trying to write an equation. We can do that equation pretty quickly. We know it's, since it looks like this, we know it's going to be y equals x squared. Y equals x squared form. So let's do our y numbers. Y minus 3 equals, our a number was -1/4, we just found that, times that quantity x plus 2 squared. Now if I want to graph it, I don't like that 1/4 using the pattern, so I'd probably just make a table. Let's make our table. And if I plugged in 2, let's plug in 2 and 0. Actually, I'm just going to start with plugging in 2. If you plug in 2, you can follow that math through. The red is where I actually did the calculation, but y equals -1, so we're looking at the point 2, comma -1. 2, comma -1 is right there. And if you think about the symmetry, you're 4 away from the middle. You can tell from where the vertex and the focus are. So go 4 on the other side, and you have another point. Okay. If I plug in 0, I'm going to save you some time with the step. But you plug in 0, do the work, you're going to get 0, 2. So I've got this point 0, 2 right there, and then it's 2 away from the middle. So go on the other side. You've got symmetry, and you've got a point over there. So remember, we know this vertex is right here. We can draw our curve. That's our parabola with focus at 2, -2. Give the domain and the range. The domain, the x numbers, looks like all real numbers. And the range is going from -infinity up to +3 inclusive.